We're now on to example 5. In this example, we are considering a set of problems on the left side of the page and a set of problems on the right side of the page. For now, let's focus our attention to the left side of the page. It says here that we have a function f of x equals x squared minus x plus 5. Notice that the graph of this function has been given on the interval from x is -2 to x is 7. It's a parabola, open up. I can see also the derivative of that function. So if we started with x squared minus x plus 5, its derivative would be f prime equals 2x minus 1. And this graph has also been given on the interval from x is -2 to x is 7. The question we're being asked is to consider the integral, the definite integral from x is -2 to x is 7. I want to show graphically what this definite integral actually represents on the graph of f prime and what that definite integral represents on the graph of f. So first, to find the integral of f prime of x dx from x is -2 to 7 means we're going to find the area between the x-axis and the rate function from x equals -2 to x equals 7, where we count any area below the x-axis as negative. So we first have this little triangle over here that spans from x equals -2 up to x equals 0.5, where this function has an x-intercept. The area of that little triangle can be found with 1/2 base times height. In this case, the base spans from x is -2 up to x is 0.5, so the length of the base is 2.5. And the height of the function is -2. Remember, area can't be negative, but a definite integral definitely can be negative. When it's below the x-axis, we're going to get this negative accumulated change value. When I multiply that all out, I get a value of -6.25. This big triangle up here spans from x equals 0.5 up to x is 7 with a height of 13. So the area of that triangle, 1/2 base times height, will be 1/2. The base is 6.5 in length. The height of the triangle is 13. And so when you multiply that out, you get 42.25. So I have shown graphically here the representation of that definite integral. Let me just write out now what I can conclude from this. The integral from -2 to 7 of f prime of x dx has a value of this first integral value over here, -6.25, plus this second calculated value, 42.25. So overall, the definite integral is 36. On the graph of f of x, I have labeled here the point x is -2, y is 11, and this other point x is 7, y is 47. Notice from x is -2 to x is 7, f of x increases 36 units. So the graphical representation on the graph of f of x is the accumulated change that occurs in the function over that time period. So again, we can see the integral from -2 to 7 f prime of x dx equals 36. It's telling us the area between the x-axis and the rate function, where area below the x-axis is counted negative. It's telling us the accumulated change in f of x on that interval. On the right side of the page, we just have another example. Notice the difference in this green function on the right side of the page. We have a function g of x equals x squared minus x minus 10. It is the same thing as the red f of x function to the left. The only difference is that it is shifted down vertically. You notice it has the same shape. You'll also notice at x is -2, the y value is -4. At x is 7, the y value is 32. So the accumulated change on that interval is that this function increases 36. We could say for this function as well, the integral from negative 2 to 7 of g prime of x dx is also 36. The g of x function increases 36 units on that interval. G of x has the derivative g prime of x equals 2x minus 1. It is the same as this derivative on the left. If we were to find the area between g prime of x and the x-axis, counting area below the axis as negative, we would find that this comes out to integral negative 2 to 7 g prime of x dx equals 36. It's exactly the same graph, so it's definitely going to come out exactly the same. Notice if you had started with f prime of x or g prime of x and calculated those areas, you would have gotten the value of 36. You don't know if the original function f of x, g of x, is vertically above the x-axis or below the x-axis or hitting the x-axis. You don't know. All you know from the calculation you do above is that whatever that original f of x or g of x function looked like, we know it increases a total of 36 units from x equals negative 2 to x equals 7. You cannot tell how high f of x is or how low f of x is. You can only tell that it increases 36 units.